Well, I'll tell you what, let's jump into the next topic, which is AOA and energy management systems, selection and calibration. So I've heard a little bit of talk about envelope protection systems. So what's that all about? I flew an Airbus A320 and it had flight envelope protection system. So what are we talking about there? What is that? Is that something that's going to take over my airplane, Dave? What is that?
So thank you. I'll back up and give a little bit of background of the work we've been doing with FAA, as well as industry and NASA, as well as academia. We have FIT represented here today in the audience, and some other academic institutions as well. For the past 6 years, we've been partnering with these entities to perform research. And the common theme was evaluating affordable safety enhancements to general aviation. So as Charlie mentioned earlier, that's two prongs to that. There's changes to the design of the aircraft and the airfoils, and then there's some gadgets. So the gadgets that you mentioned, Chairman Sumwalt, energy management, envelope protection, AOA, they all factor in. And we have this portfolio of research projects where we're trying to really get to the bottom of what is important to display to the pilot and how that display interacts with the unique aerodynamic characteristics of the airframe. So AOA and energy are fundamental parameters. And it's interesting that those parameters are invisible normally. If you have an AOA sensor, then you could drive a display, but you can also do a lot more. And I'm going to provide information in the docket, and it's titled AOA More Than a Display. Because when we say AOA, we think, well, it's just a display. We're trying to get away from just another gadget in the cockpit that the pilot has to incorporate a visual scan. We want AOA to be incorporated in a system with smarts that makes decisions for the pilot and helps the pilot do his mission. So along that line, we embarked about 6 years ago with the FAA Tech Center doing some research projects, and we characterized the technical limitations and capabilities of all the commercially available AOA sensors. And there's about 10 of them on the market. Some of them are differential pressure, some are vane type sensors, but they're affordable. And we wanted to focus on the sensors that are not on the high-end business jets or not on military airplanes, but that are affordable for general aviation. So around the $1,200 price point or less. And we've done quite a bit of research to figure out how to package all this information. One of the other areas where AOA can be used, other than just a display, is if you use that sensor to drive tactile cueing to the pilot. Think stick shakers. Think increasing force gradients in the stick to keep pilots away from a bad area of the aerodynamic characteristics. So these are all kind of, again, as I said earlier, backing up the precursors to a stall event and trying to prevent that startle factor.
Excellent, thank you. Any comments on that? Any thoughts around the table? So, Charlie, I'm going to come to you for a moment. As you know, distractions are on our most wanted list, and it's distractions in all modes of transportation. And I understand that you've got a few examples of how distractions have led to a loss of control.
Yeah, and this dovetails in with where Dave was going with that, but I was tasked with doing a post-accident investigatory flight test program on an ASK-21 glider. And this particular incident touches on a lot of things we've been talking about: culture, the role of the flight instructor, and the understanding of the airplane. The SK-21 glider is a tandem two-seat glider, fiberglass, high performance. The Air Force Academy was using them to teach the cadets basic flight skills. Wonderful machine, and it was also designed by the manufacturer to be able to provide spin training. But as we all know, with some airplanes, if you have two heavy folks in the front, you end up with a spiral instead of a spin because of the CG control. So they manufactured it such that you could put spin weights on the tail to control the CG so that any set of pilots could actually spin it. They scared themselves, the instructors did, because when you put tail weights on, you have heavy folks in the front, you're actually affecting the inertias of the airplane. And so it actually had a very oscillatory spin mode where it would enter into a spin nose low and then it would wrap up in speed and it would make it go flat. And they thought they were getting into the proverbial flat spin, and they had never been instructed about the characteristic. If they just waited a little bit, it was going to slow down its spin rate and fall back into the tighter spiral and then come back up, and it would oscillate literally 50 degrees of pitch attitude until you effected a recovery. So they scared themselves so much, they decided to stop spin training altogether and just stayed away from it. That was mistake number one. Mistake number two was then they were out one day and they didn't understand that this particular airplane could also enter a spin stick only. So a lot of folks that don't learn stick and rudder skills very deliberately tend to get lazy with their feet. And this particular instructor had a guest, spouse of another instructor on a family day, doing some ridge soaring, so relatively low to the ground. The instructor got distracted for a bit. When he looked back, he saw, geez, I'm too close to the ridge, made an instinctive push with the aileron, which caused enough adverse yaw to create the side slip necessary to enter a spin. Turn and a half later, nose hit the ground, and unfortunately it was a fatality for the front seater. So we put it through an entire very rigorous test program out at Edwards to re-clear the airplane, and then to provide a training program for the instructors at the academy so that they could properly use it and understand it. So, you know, the ability to understand energy management, the performance and behavior of the aircraft at these low speeds is a very critical, and that example, I think, points out very well what we are about here.
Thank you very much. Dave, do you have any thoughts on lessons from FAA flight test as it relates to loss of control?
Yeah, and I'll try to tie those back into what Charlie just alluded to, which is energy management. You know, in doing the research with the AOA sensors, what we were looking at was enhanced stall warning systems. So not just the sensor that goes off with a horn 5 knots prior to the stall. So enhanced meaning you have earlier warnings that lets the pilot know when his energy is decaying, and you feed that back with tactile feedback to a stick shaker or like I said before, changing force gradients. So the things that we were looking at are specifically aircraft energy state and AGL altitude. As Remora Systems just pointed out, what was the statistic? 80% of stall spin accidents, fatals, are below 1,000 feet AGL. That's really the area that we have to be in tune with. And I equate this to flying an ILS. For instrument-rated pilots, as you know, you fly an ILS. As you get closer and closer to the ground, the tolerance for your error gets tighter and tighter. And so we're embarking on some additional research focusing on feedback to the pilot on this notion of an energy funnel. As you're getting closer and closer to the ground, you're going to have cueing systems that provide feedback about how precisely you're flying and if you're getting into danger. And we don't want just another video game or gadget in the cockpit that you have to scan. We're focusing on the pilot's doing his mission and having the system in the background kind of monitoring the pilot's error tolerances and making sure that he or she is performing as need to be.
Excellent, thanks. Charlie, now I understand that on the topic of aircraft that are spin resistant but have a high drag airframe and low horsepower engine, you've got some thoughts on that.
Yes, thank you. So as we've been alluding to here, the topic is energy management and how we can bring that into the suite of tools to manage loss of control. So angle of attack, we talked about, side slip, the skidding turn. The other thing is energy management. We talk it as instructors, but what does it really mean? So total energy of an airplane is dependent on both altitude and airspeed. So earlier we talked about what's more important, altitude or airspeed. Actually, it depends. But they both contribute to total energy state. And then with our engine, thankfully, we have the ability to add to or subtract from that energy state. And the ability to climb or accelerate is called specific excess power. When we go out and do flight tests to create the best climb rate speed, VY, what we're actually finding is the point in your envelope where you have the maximum specific excess power. That's your ability to climb or accelerate from your current condition. So if you are at high altitude with a low power aircraft, a heavy gross weight, we all know that, you know, out at Salt Lake where I live, a Cessna 150 or 172 barely gets a couple hundred feet a minute off the ground and takeoff at full power. But once it gets to VY, it has its best climb rate. So is the thought here is, as we integrate cueing to the pilot, the best place to be when you're below 1,000 feet, as a matter of fact, is at VY, because if you're at VY and you add full power, that's your maximum ability to climb or accelerate from that condition. There's no reason to be below VY when you're below 1,000 feet if you're not turning on final, getting ready to set up for the landing and having an intentional need to bleed energy. So what we're talking about is, can we do something with that without having the pilot have to decipher a bunch of digits in the cockpit to give him a sense that he is running out of energy, and if he doesn't do something about it, the Airbus, the modern ones, have an energy warning system that from any given state, if you can't change the vector to positive, it will warn you, speed, 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 add power, right? So that's the kind of thing we're talking about.
Great. So let's talk about some of the technologies that can help us with energy management. Dave, give us a perspective of that, and then I want you all to help fill in the blanks here. What else do we have?
So energy management, I go back to the technology. I'm still amazed from 1980s technology that Charlie could take a glider from 250 nautical miles up and land it on brick one from 17,500 miles per hour. So that's pretty amazing. That's energy management. But if NASA could do that in the 80s and 90s, certainly I think we can tackle this problem of energy management for the recreational GA pilot. And one system that we are doing some experiments with right now in collaboration with NASA Armstrong and NASA Langley relates to both loss of control of energy and control flight into terrain, which is the #2 killer in general aviation. And that system is called automatic ground collision avoidance. It is a system that NASA and the Air Force developed back in the 90s. I flew it on the F-16, and it is now fielded on the F-16 and the F-35 Joint Strike Fighter. What I'm trying to do with this latest research project is to bring that technology into GA cockpits. And what we're starting to do is look at just a manual ground collision avoidance system. So we've developed with NASA an algorithm that runs on an iPhone or an iPad, and it just runs in the background. Say you're running ForeFlight or any other app on your iPad. This algorithm runs in the background. It knows your AGL altitude, and it knows your energy state, and it looks at the terrain and the obstacles around you and provides viable escape maneuvers based on the aircraft performance and your current energy state. So we did a test 3 years ago with NASA Langley and flew it on a Cirrus SR-22 with really good results. What we're looking to do now is partner with somebody, AOPA or any other industry, to get this out there for the general aviation flying public. And we have a database that is 100 times more accurate than a TAWS database, and it holds a lot of promise for general aviation.
Wow. So you did mention Charlie's ability to go back and land a glider and manage energy. And so technology is very much part of the answer. But back to this morning's discussion, there was a lot of training involved in that too. I mean, so you've got to have both, and that's why we've structured this roundtable to focus on training and technology. So, so any other thoughts on innovative technology that can help us with energy management? Jens?
Thank you. One thing to just build on what Dave is talking about, it's the fact that it's not only in the research phase. I know we're going to get into the standards here shortly that we're looking for new aircraft, but this concept of different types of enunciation to the pilot, you get the inputs from whatever inputs you need them to come from. But we're now, thanks to our human factors experts, learn things such as the difference with a pilot understanding a visual cue, a single beeping sound, a voice cue, the stick shaker, and then in some of the new aircraft that we have out there today, full electronic stability protection where the aircraft doesn't only give you the cues, but then helps you with the recovery. That's the path that we're heading down for in both new technology. It's a little bit harder on the retrofit, but especially in new aircraft where that full spectrum of different cues back to the pilot, from the very simplest, that in some cases, that stall horn, it can be viewed as a nuisance, to the more complicated ones that give you more feedback. That's where we really want to go over the next few years. So the standards are just on the cusp of being put into the books for the use on the broader industry.
Great. Other thoughts on that? So, Mel, please.
Yeah, I was just going to add that I think this is an area where we can contribute. As you spoke, we have many different people here in this forum to try to help solve this problem. And as far as aircraft certification services is concerned, we're trying to find ways that we can contribute to try to help as well. You can't deny the importance of training and try to help improve pilot proficiency. And what we're trying to do is try to help and change the paradigm slightly, because you train to the equipment you got to go use, right? And so some of the things that we're trying to do is to try to find ways to bring into the general aviation community equipment that provides assistance so that you reduce hazards, so that the types of training you're doing is going to help enable those hazard reductions.
Excellent, thank you. So we want to talk about, continue this line of thinking to talk about industry efforts to reduce loss of control and mitigation strategies. So Justin, I'm going to ask you a question, and Jens, I'm going to ask the same question to you. So Justin, where is the energy right now? I'm not talking about aircraft energy. Where's the momentum with equipping GA aircraft with newer technologies to mitigate loss of control? And give us a high-level response.
Yeah, I think we've made as an industry very considerable progress in this area. One of the biggest questions that we always get from members is, why can't I take my piece of avionics that goes into experimental aircraft and put it into my certified aircraft? It's probably the number one question we get in this area. There's a lot of misunderstanding. Obviously, there are reasons why things need to be certified. There are additional limitations that get removed and various other things. So it's really about how do we bridge the gap between what's been very costly to get these products into the certified world from the experimental world. And if you look at it from that standpoint, there's been a huge delta between the costs that it takes to get a certified aircraft versus an experimental. In the past 2 years, we really have bridged that gap, I think, significantly, particularly in the area of electronic flight instruments, autopilots. We've talked angle of attack indicators a lot today, but Garmin and TrueTrack and Dynon, a lot of these companies are putting out some pretty great products, and I think it's a credit to I think everyone in the industry, the manufacturers, the owners and operators, the associations, and really the FAA, a lot of the leadership that they've done. So I think we're making progress, and again, the huge part is the affordability of it, because there were previous products available for the certified world, but they were just too costly and no one was using them. And it's not any good if no one's using it. You can't reduce safety. You can't improve safety if nobody's putting this stuff into the cockpit.
Great, thanks. Jens, take a whack at that one.
Yeah, just to complement what Justin said, again, great progressive policies coming out of the FAA for things like vacuum systems that we've modernized. The FAA's done all these spot policies to really address the legacy fleet. Gamma's energy has gone into Part 23 reform. Part 23, for those of you not familiar with it, are the rules that govern small airplanes. They went into effect last year. It had taken us on about a 6-year journey to get there. Proposal back in 2013, 2014. Generally supported by everybody, and the framework is to take 800 very prescriptive requirements in the legacy rule book that nobody had touched since about 1986 and boil it down to 300 to 400 safety specific items that are very performance based. We then took the means of compliance, the specificity, and put it into a standards group. It's called ASTM, and they have a group called F44 that holds the old standards, but it's also giving us the tools to bring a lot of these new standards that R&D efforts are out there doing work on for loss of control, and things like icing that I know is of key interest to the NTSB. This is a group that has a much higher ability to turn new standards. The FAA touches rule sets pretty much every couple of decades. Industry is now moving much, much faster than that. So this week, the group that owns all the standards for small airplane is actually meeting about 3 days in a row. They're over in Cologne, Germany. One of the focal areas for aviation regulation is here in Washington, D.C. with the FAA. The other one is EASA over in Europe. And they are updating the standards. And just here next few days, maybe next couple of weeks, we expect the FAA to come out and recognize the first new iteration of the standards for small aircraft. That's really going to help us bring the type of technologies that are out there in the experimental space, the type of technologies that are undergoing R&D, bring them to the market on both new and legacy aircraft, because a legacy aircraft can obviously step up to the latest standards and use them.
Thanks, Sean. Do you have, would you like EAA to weigh in on that?
Sure. I want to definitely highlight for our listeners and participants, we just created, working closely with the FAA, 2 brand new of these new era STCs, one for the Dynon D10A electronic flight instrument, as well as the TrueTrack autopilot system. Low price points that previously had never been seen for some pretty advanced equipment, including in the autopilot's case, a modest form of envelope protection for $5,000. So we're very excited about what these mean to the industry and to the general aviation community. But it's important for our listeners to understand that has happened because of the way the agency, the FAA, Mel and his team, are looking at a new lens. They call it the safety risk continuum, and basically where the article or the concept or the solution lies on a risk continuum as far as what kind of unintended consequences can this impose? What are, if it fails, what's going to happen? Those things are allowing us to bring to the forefold what previously we couldn't do. A lot of innovative technologies, and you're going to see more in the future. It's really taking off. Other companies are now doing it. It's exciting. Well,
that's great. And to the FAA, thank you for being, as it says there on your name tag, policy and innovation. Thank you for being innovative. So Sean, you mentioned envelope protection. That's something I mentioned a little while ago. What is that? If you get slow, what's the airplane going to do?
Well, it depends on the system. In this case, it's a simple 2-axis autopilot, so it's really based on attitude of the airplane, not necessarily airspeed. But bank angle, for example, the yoke will literally start to push back on you if you have the mode selected and you exceed a certain bank angle. So it's really about basic elements of airmanship and providing that pilot with additional data when they're distracted or startled that could be useful.
Great. Jens?
Yeah, and just round that out. The new standards for small airplane design have a requirement that the aircraft cannot have an inadvertent loss of control.
Say that again. Cannot.
New aircraft that will be designed to the new standards cannot experience an inadvertent loss of control.
Cannot experience an inadvertent loss of control.
So the nice thing is the rule is very easy to write. The means of compliance is what we're building on here with the various efforts that we've discussed. Improve data into the aircraft, making that use of data in the cockpit much, much easier through R&D efforts, through various feedbacks to the pilot, to designing airframes a new way. This new aircraft evolution that we're going to see, how the new Part 23 is going to be structured is going to be an improvement in specifically this area.
That's fascinating. Mel, why don't you weigh in on that?
Yeah, I was just going to mention that the rewrite of the Part 23 standards affects new airplanes being designed, but it doesn't help us with the 200,000 airplanes that are already out there. So that's where we're trying to work very closely with industry partners doing research to try to find ways to affect our, through policy, the inclusion of, and I guess I go back to what Sean was talking about. It's a whole ecosystem. We're really lucky we have such a flourishing experimental fleet. They do all sorts of very interesting experimental kind of work that we can then try to find a way to bring into the certified fleet. And there's a different expectation depending on what kind of airplane you're going to buy. If I build a home-built kit versus I'm going to buy a Part 23 certified kit, I have a different expectation of what I'm going to get. And so this whole ecosystem of different classes is helpful to help bring technology along, do the experiments in the experimental area, and help bring, and we've been working very hard to try to find where do we inadvertently have barriers that stop that from coming in, and we're trying to break those down so we can bring the safety type equipment back into the certified world.
Great. So Justin, what more can you tell us about the industry efforts to bring new technology?
Yeah, from our perspective, AOPA's perspective, I mean, we've been really, I think, impressed with how the industry is collaborating, and I think each of us have touched on individual elements of that collaboration, but there's really kind of a confluence of different things that have kind of come together over many years now that have really brought about this change. I think number one, most importantly, is there's a lot of demand for this. We hear it from our members all the time. EAA does as well. You know, owners and operators want to update their fleet. The average age of a GA aircraft in this country is about 37 years old. Single-engine piston airplanes' average age is about 45 years old. These planes are aging, and people want to upgrade it. So there's a lot of demand out there. The second thing is there's been a lot of really great products developed in the experimental community. I've obviously seen a bit of a digital wave here in the past decade or two, and a lot of these new products are coming out are very software-driven. They're very dynamic. So there's a lot of great products in the experimental world, and it's a question of how do we bring those into the certified world where there's a lot more demand for them. And that's where I think the FAA, the manufacturers, and the owners and operators have come together, have been rethinking the certification of these products, especially the ones that are digital in nature. How do we rethink, how do we verify the software and certify the software in these products? How do we rethink a lot of these things that have been going on for decades?
Super. Malcolm, we haven't heard from you too much. Tell us what ForeFlight is doing to prevent loss of control in flight.
Absolutely, thank you. From our perspective, a lot of the technology that we're dealing with on a regular basis is more in the portables. There's the experimental stuff, there's the panel mount stuff. Some of the panel mount stuff starting to now open up to connectivity so that we can read information there. But our play is really a hub of information in the cockpit. There are a bunch of sensors, there are some tactical instruments and things like that. We are trying to bring in technology that allows us to log and analyze and also to critique is kind of something where we're starting to look forward to. So there's many pilots use ForeFlight, and many people log their flights. We have millions of track logs up there in the cloud. And so one of the thoughts is how do we start to look at that data with obviously the pilot's permissions and try to look for trends, both industry-wide but also just personal. What is your speed? What is your delta off of a glide slope or something like that while you're on approach? And then start to look for patterns. The iPad, as you guys know, is essentially a supercomputer. It can do billions of instructions per second. The new versions of it can do machine learning on the fly and things like that. So really where we look at our role in the industry is accepting sensor data, working with the panel mounts, experimentals, the portables, bring all that together, be the hub of information, and to be able to start to do the analytics both in post-mortem but also in real time. So that's...
Great. So for everybody or anybody that would like to speak up, what additional innovation would you like to see that's not necessarily mature or on the drawing boards? What would you all like to see? What else needs to be out there in addition to what we're hearing about?
Well, I'll go first. There's, again, using that safety risk continuum, there are many other technologies around fuel management, engine management, things that previously have cost a high amount of resources and dollars to get into a standard category aircraft cockpit that we can do in a much more affordable way that will greatly enhance the overall situational awareness of every flight.
Great. Mike?
I'd be interested if there's efforts in the nature of geometry in the pattern. Your downwind's too tight, that type of thing. If there's some efforts in that area to alert the pilot to geometry issues.
Mike, we can help with that. So one of the items that's come out in some of the light GA work that we've done on the flight data monitoring front is exactly that. So how does the pattern look? So part of the tool set we've developed, we actually have a tool that will help a pilot or an organization understand turns to final and what's the risk of a loss control during that turn. And we can grade that and give you kind of a historical view of all your turns to final and how close you were to losing control and where were some of the riskier. Just to let you know what the trends are, what direction you're heading, and to monitor, have you corrected that, and is it going in the right direction? So, we've got a few schools that are currently hopefully getting ready to test that for us. The tool is kind of in the final stages of development, but some of the early work looks very promising.
Charlie, please.
One stab at your original question there. I think if we look at what transpired in the airlines and in the military with crew resource management, a dramatic change in the accident rates when you take a different approach to how you self-critique, debrief, and also catch trap errors in real time. We've made an effort to do single pilot resource management, but I don't think we've been very successful. Substituting for the other person in the right seat is pretty tough when there's no one there. However, some of the things that Malcolm's working on, we have tools like flight risk assessment tools. Pre-flight, you fill out a questionnaire. You have post-flight the ability to debrief, where the guy that was sitting next to you could say you were a little high. You've been doing that the last 3 or 4 flights. That data is all in his equipment, and if you added a little bit more from the airplane itself, like throttle position, actual indicated airspeed, the pedostatics, your actual aircraft configuration, now it could tailor to the way you fly that particular airplane, could give you an automated data output of where you weren't meeting standards for expected aircraft control, and you're getting continued. Every flight becomes a training flight. So I think there's a lot we can do that starts to scratch the itch of missing that second person from crew resource management, that these devices can provide that.
Thank you. Let's go to Jens and then back, then over to Malcolm.
So the technology that Corey and Charlie discussed here, this ability to data mine how we're flying, the technology is there. We can do it today. The challenge that we're really working on in some of these groups between FAA and industry is I can get into a flight school, I can get into a flight department. That's easy. They do active risk management. They have somebody looking at the data and they're providing the feedback to the pilot. We haven't been able to get past, in the same manner, getting it to the individual pilot. As Sean points out, they're out there to have fun. Do they even want to have their aircraft under a degree of monitoring? So I wish I had a solution to that one. If somebody can come up with the way to get your typical GA pilot out there to actually do active data monitoring, how do we get that into the culture of aviation safety? Make it a fun thing. If it's your, I have a running app that tells me how I did. Do I want to have the same kind of flight app that kind of kicks back and tells me, hey, this is how your flying is going, Yeah. Whoever can invent this, where are the innovators in the room right over there behind you, Chairman? Let's look at that Fitbit for aviation. I like that term. How can we get to that point where people truly want to embrace flight data monitoring?
Fantastic. Malcolm.
Yeah, I was just going to go back to your previous question about what technology you'd like to see. One hope that I would love to throw out to industry and to all the controlling bodies is unified standards on communication. So one thing we saw with the ADSB standard, for example, was it was very simple to consume those feeds. You didn't have to have a very custom XM, for example, a very custom feed, and this receiver is a different feed, and this receiver is a different feed. With the ADSB feeds, we got that. For all the stuff Charlie's talking about, very similar. If we can get engine monitoring and the 50 hertz AHR, or stuff coming off of the G1000 and things like that, that would allow us to take these algorithms and make them even more performant. So that would be my request to everyone.
Fantastic. Well, I'll tell you what, Sean, I want to come to you and talk to us about what the EAA has done to spur innovative solutions. And I think the Innovation Prize is a great example. It spurred some good innovation. So let's hear some of your thoughts.
Sure. I've already described a lot about the Founders Innovation Prize and also our SDC work and working with the FAA and creating, helping to create and partnering to create, along with AOPA and others in the industry, much lower barrier certification policies for the appropriate low-risk equipment that can greatly enhance safety in the cockpit. As I said, we personally at EAA now have 2 STCs that we are supporting the industry with and partners with those manufacturers. We've helped streamline the parts manufacturing approval process, or PMA, with some prototype efforts along those lines that will now become codified into longer-term policy, which will hopefully also reduce barriers for manufacturers to actually manufacture certified equipment. But we've also worked a lot on the operations side, on pilot safety side. For example, in the experimental world, our most riskiest phase of flight is phase 1 flight testing. And Charlie and I and the safety committee worked to partner with the FAA and create a new advisory circular and a new process called the Additional Pilot Program. Brad, that was with your shop. And we've seen a tremendous benefit out of that right out of the gate with those that are building their first project, able to take a qualified test pilot with them that's got the right qualifications indicated in a risk matrix that they perform, and go out and fly as a 2-crew operation in those phase 1 test flights. And it's greatly enhanced safety in that arena. We're about to roll out XP3, which is a comprehensive test program for those amateur builders as well. There's a lot of elements, a lot of lessons in these tools and these creations that will also ultimately affect the standard category world. Because as we've talked about, a lot of the innovative things that happen in the experimental side morph and mitigate their way to the standard category world over time. So we're excited to be that catalyst and help reduce barriers so that the process can happen even quicker.
Thank you very much. So Malcolm, I want to come back to you and talk about ForeFlight's innovation story and what ForeFlight's plans are for the future as it relates to loss of control.
Sure. Quick history. The company was started by 4 pilots, generally to bring a gap in the market, which was there was no portable information that you could carry around with you. So they brought METARs and TAFs that were available on aviationweather.gov, brought in airport information, and brought it all into a HTML phone app originally. Then the iPhone 2 came out, and then the iPad 1 came out, and that was a huge pivot. That's when you suddenly had GPS and things like that. So sort of the history there is, and then just sort of progressing. We have charts, procedures, ADSB. We now have a military flight bag product and things like that. So all of that was really driven by the market. The market was asking, this is what we want, this is what we need. We need more information to make our go, no-go decisions. That's really where we started. Now we're more into, you can get your go, no-go by looking at weather, downtrack, things like that. Some longer-term visions on that. We'll try to assist you in some of that to be able to look, especially if you're going long across countries or things like that, look at various factors that might make you not want to blast off. I think up until now, EFBs, so there's a classification where there's several products like ours, have really been around pre-flight and in-flight. I think with the addition of all these interfaces and all of this connectivity in the cockpit, and I'm excited about the Remora stuff, many people are starting to build products to bring to the 200,000 that are already out there. So what we're interested in is integrating that, building out predictive analysis on watching what you're doing and be in the right seat, being able to debrief you after the flight, look at your historical flights and to be able to look for patterns. If we can get engine data, we can start to see, like, Salt Lake, a great example is I'm going to go out and do some mountain flying. And one thing I'd love to see is flight over flight over flight, what's my VSI coming off the runway? And if that starts to decrease, maybe I've got an engine problem. I mean, those are things that we can start to do and not need this huge database. We can actually do that just for the individual pilot if they don't want to contribute into the market. So that's really, looking forward, our goal is to help write in the loss of control, which we're not going to build an AOA device, but we want to give you the predictive and now analytical tools to see whether or not you're vectoring towards an event, and we have that ability because of the. So.
Thank you very much. We'll go into the final topic, formal topic area before we start taking questions. But let's talk about reducing regulatory barriers. And Mel, I want to ask you about this. I think you've talked about some of it, but how has the FAA worked to reduce the regulatory barriers to spur aviation innovations? And so I'm going to ask that to Mel, and then we're going to go to Jens and Sean to see what your thoughts are. But please go right ahead.
Yeah, thank you. So I appreciate that question because that's been a pretty energetic conversation within the aircraft certification services. If you think of development of products in isolation to costs, then sometimes you can say, well, we can increase safety just by making the requirements more robust, more rigorous, and so forth. What we've started to look at is how does what does the policy and the development of standards, how does that impact our ability to actually get them into the aircraft? And so as we've been doing that, sometimes we've discovered that we have either been overly conservative on the requirements. In other words, we've looked at things like software policy or EMI or lightning protection policy, and started to see where we've actually required more from the manufacturer and designer than is actually needed to be able to mitigate the hazard we're worried about. So as we've been doing that, that directly relates back to cost. If we're going to require more rigorous software standards where it's not required, that's just time that a manufacturer or developer has to spend in doing work that actually has no safety benefit whatsoever. So we've been very self-critical, trying to look, and luckily we've got critics that are willing to help out with that. And we encourage that kind of feedback, because what we're trying to do is try to find ways to make sure that we bring the level of rigor, the requirements that are needed for development of these products to be in line with the kind of hazard that we're trying to mitigate. And it's been very successful as we've been looking through. In particular, I think we've made some good headway on software development. We're making some really good headway on EMI and lightning protection. But we're trying to be open to looking at all those. Now, of course, the big long-term play that we've been working on strategically is a Part 23 rewrite, where we've taken our a more prescriptive rule set and we've changed them to a more performance-based rule set, and then using consensus bodies to help us develop standards that are appropriate. Those consensus bodies will then help us be more, hopefully more agile and being able to come up with standards that meet those performance objectives that are now within the new rewrite. So we think that's going to help for the long term. In the meantime, we're looking at our existing regulatory and policy set to make it more in line with the safety that we're trying to get.
Mel, thanks for that. Jens?
Thank you. I'll do a trip down memory lane. I mean, this is a long journey. It's culminated in Part 23, but the FAA has made several progressive decisions, and yes, industry has pushed, but it's been very cooperative. Changes to what's called 1309 for light GA. That was done in the late 1990s, that system safety assessment of designs. The FAA, in one view, was actually reducing the requirement, and everybody got worried because a reduction in a requirement is obviously bad for safety. No. It actually allowed us to start bringing some advanced technology from air transport into the GA aircraft, because we could build it at a price point where it would be affordable for a 172 or a Piper or a Cirrus. Very progressive step. The debate around EFBs when it started was very interesting. First of all, everything had to have an aviation pedigree. And then the iPad came along. And to everybody's happiness, we were pleased with this decision. The FAA said, yeah, you can use an iPad in the aircraft. Go ahead. Real progressive decision. It was one of the first times the FAA did not require this jumping through hoops. And if the FAA had made a different decision here, I believe that at least one person at the table might not be at the table right now, and we wouldn't be using the great information technology. They're very progressive. And what does that let us get? A great deal of situational awareness and information. And then on the cusp of ADS-B, I can now get traffic into the aircraft for a few $100s, courtesy of these devices. Very, very progressive. Weather, it may not be the first thing you think about with loss of control accidents, but when we look at factors that are driving loss of control accidents in the studies done by the GAJSC, access to good weather information before flight, weather cameras, good flight briefings, but also in flight, in the real-time environment, that is really, really important because it's a precursor to some of the loss control events there. And then we've talked about Part 23. We're obviously very happy about it at Gamma. A colleague of mine had the opportunity to chair the group, and the work is continuing. Having it published last year was not the end point. It was a starting point where we had transitioned over the old rules, the rules from the mid-1980s, and we're now doing the work on the things that I mentioned. New approach to loss control, a layered approach. It's not just a simple design requirements. You really have to look at the full aircraft. Icing, a popular topic again that the NTSB has talked to us about. There's been some interest in that in GA aircraft. The new forum that we have working these standards, instead of letters between the NTSB and the FAA and industry, which were sent out, when the NTSB sent us a letter, Gamma and FAA, we got the same one. We wrote back to your experts and say, NTSB, how about you bring them to the next meeting of the ASTM group and you present your concerns to industry's experts and FAA's experts and also experts from Europe, Canada, Australia, New Zealand, and then let's roll up our sleeves and actually write the standards for how to do icing. The G analysis started looking at, we have a frustrating number of fuel exhaustion accidents. The new standards required to have a more sophisticated fuel enunciation and alerting system in the aircraft. It's a really new way of working with things. Again, we're only 8 or 9 months into the environment, but there's a good news story there for both innovation in the industry, but also advancing some of our key safety challenges.
Thanks for outlining all of that. And Sean?
Yeah, Chairman Sumwalt, the only thing I really have to add is what we're now experiencing with this prototyping work that we accomplished over the last 18 months, and that it's kind of the field of dreams approach. If you build it, they will come. When we first did these first prototyping STCs, there were quite a few of the existing long-standing manufacturers that were quite concerned, saying, hey, wait a minute, foul. This is a different playing field. This is not what I had to do. Now that we've shown, look, there's a whole new market out there. There's people that otherwise would not have gone down the path of these safety-enhancing equipment because of the cost barrier. By lowering the certification costs and the barriers to getting them into production, we now see most, if not all, of these long-standing manufacturers now also pursuing their own product line. So that's exciting. We're seeing a cultural change within the avionics industry with this work that's being done.
Great, thanks. We'll now go to the questions we've been getting from the audience, and which includes online audience. And Member Weiner, we'll start with you, sir. What do you have down there?
Yeah, this is an online question. The GA pilot, quote, interface, unquote, directly moves flight control surfaces. Some digital flight control systems differ. The pilot sets a pitch angle and roll angle using the yoke or stick, which is then maintained by the digital computer. Let's say this technology could be effectively and redundantly developed. Does the panel believe this would reduce loss of control accidents? If so, is this the direction a new GA research and designs should go? Sounds a lot like controllable steering. I mean, with what we've got in terms of digital autopilot capability nowadays.
Yeah, so I wouldn't mind answering that. Of course, FAA is not in the business of choosing winners of which technology is going to work or not work. But I will say that that is a very promising area. In fact, I was thinking about this earlier. We're kind of at a confluence of a lot of technology right now. For example, with you look at the unmanned airplane system community growing in strength, and the technology that's being coming in to that area with inherently unstable air vehicles that have to be maintained, controlled through flight control laws. All that obviously can be brought into general aviation in some form or another, and I think it will influence the development path of general aviation. Will it be retrofittable? That's using Jan's word here. That's always another question that's difficult to answer. But certainly, if you're able to have flight control surfaces that are being controlled and manipulated through flight control laws, you can do a lot of envelope protection that can help people stay out of areas of trouble. But there's a lot of work to go in to get to that spot. I don't know if you want to add anything, Dave.
Sure, thanks. I'd like to add that there are no certified fly-by-wire aircraft in Part 23 yet. So the FAA has certified Airbus, Boeing, Dassault, Gulfstream, and Embraer fly-by-wire Part 25 aircraft. We have already received the first application for a Part 23 fly-by-wire aircraft that's fully fly-by-wire. And as Mel alluded to, with fly-by-wire, you can sort of take care of some of those bad aerodynamic characteristics. In addition to that, you can build in these envelope protections: angle of attack, G-loading, low speed, high speed, bank, pitch. You can bake all that into the basic flight control system. I think it's very fascinating to think about the future with fly-by-wire aircraft in Part 23 that are maybe not for the recreational pilots, but maybe for the urban air mobility or aircraft that are used in commercial service that have 1, 2, 3 seats, may have a pilot on them, may not. So it's an exciting time to be in aviation. Ramor, you're lucky to be as young as you are.
Well, great question from the audience and great responses. So, Tim, you're up next.
All right. I think this one's for some of the CFIs on our panel. It says, in 100 years of aviation, an understanding of aerodynamics and simulation has not been enough. On-aircraft training appears to be the only way to experience the dynamics of a loss of control and the understanding of what is required for an effective recovery. Is it possible to further integrate on-aircraft training for every pilot to address spins and stalls? And that's where the question ends, but I know that you'll just say yes, so I'll add to that a little bit. Do you have some suggestions for this particular person in other ways that they can integrate on-aircraft training for every pilot to address spins and stalls?
To be honest, it doesn't necessarily have to be on aircraft. Obviously, I hate to say it, there are some instructors who will go out and do spins in aircraft that are not certified for spins. There's a reason why they're not certified. However, and I do know, and I'll confess, in the days before we run the Pilot Proficiency Center, and I've got a little time to just have some fun in the Redbird, I've looped them, I've spun them, I've aileron rolled them. It can be done in this equipment, and we can learn the proper responses. We were talking earlier about it. The typical startle response is always going to be a pull. We see this all the time. We can train out of that using these simulation devices. So it does not necessarily have to be on airplane. And if you're thinking about doing it on airplane in an airplane that is not certified for this, you're certainly taking your life in your hands.
I'll just amplify that a little bit. You have to recognize that every airplane is also going to have a different set of characteristics. some of the most spin-resistant airplanes I've worked with, you can barely get them in if you work really, really hard at it. If you're lucky enough to get them in, they're really, really hard to get out. Other airplanes, you can, they go in and out like just cutting cheese with a knife, But so you have to really recognize when you say on-airplane training, what does that individual fly most? Is it that kind of airplane that he can train in that? And if he decides he needs the stall and spin training on another aircraft, what's the transfer of knowledge and transfer of training that's applicable to the airplane he flies most? So that's a very involved question. I am a very big fan of, the aerobatic kind of curriculum that Patty talked about, including a knowledge of the fact that you don't evaporate when you go past the stall, you don't evaporate when you go into a spin, you don't evaporate when you're upside down in an upset. You actually learn what that's all about, and that with the right altitude and energy management, you can get out of those things. That in itself is very, very, very valuable, regardless of the airplane you're in. And then you have to know with the particular airplane you fly, what are the boundaries and what happens on the other side of that boundary? How forgiving is it? How resistant is it? And how able is it to recover? And you just need to respect each airplane's limitations.
So I would agree with Doug, that there are things that you can learn in a simulator, techniques that you can practice. And I would certainly agree with Charlie that the transferability of the techniques used in an upset prevention recovery training curriculum are very important. But we have certainly seen value in adding upset prevention recovery training to the curriculum. We're seeing students, this is anecdotal, this is not a study, but I've seen that CFIs who've gone into deep stalls in an extra 300 and been inverted and flown in that flight regime are less scared of stalls, when they get into their Cessna 172. So I definitely think there is a lot of value in on-airplane upset recovery training, and the FAA has put out some great resources with AC 12111, AC 12109 that formalize what will get you out of a spin in every airplane, what will get you out of an upset recovery situation that's transferable to a Cessna 172 and it's transferable to an Airbus A380.
Just to add what everybody else has kind of culminated here, it truly is about aircraft control. Everybody that pursues flying, you should always be focused on how do I continually improve my ability to master aircraft control. None of us ever master it, by the way. But the bottom line is if upset training is outstanding, that's a wonderful way so that you don't even ever get startled. When the airplane does something it's not supposed to, you've been there, you've done that, you understand it. You go, oh, doggone it, don't do that, and I'm going to make you do the right thing. Tailwheel training, glider training, all of these things that make you better airmen, it's so important to being a safe pilot.
Just a comment about the extent to which simulators can be used effectively. Since a lot of the kinesthetics in upset recovery are dynamic, and the simulator can't follow the trajectory of the airplane that they're simulating, at what point is it negative transfer of training or not learning effectively?
I think you're on the right track there. I've taken the upset recovery training that flight safety provides for the citation community, and some of their setups actually are improper because the way the flight path vector is put together in the simulator doesn't mimic what the airplane would actually do, and so they run a little bit afoul of the limitations of the simulator to produce a particular upset situation. And the simulator doesn't respond the way the airplane would. So it's hard to replace the airplane for that kind of training in my mind.
Okay, next question is from a new private pilot with 160 hours of flight time. I've noticed myself neglecting to look at the airspeed indicator in the pattern. What are some tricks I can use to avoid this lack of awareness? Just saying being aware does not seem to work for me. And second, what technological advancements are on the horizon to help with airspeed awareness in the pattern. And this triggered a question I'm curious about. In the Beach Jet, we had an airspeed trend indicator that was very useful, showed where you'd be in a few seconds down the road. It was so useful that the instructors would have a tendency to want to pull the circuit breaker, so the students wouldn't have that advantage of the airspeed trend indicator. So on the technological, the second part, is there some opportunities, and how easy are they to put an airspeed trend indicator? In the first part, do you have any tricks in the pattern?
I can't speak to the second part, but the first part, and I know all the CFIs who would agree, is to incorporate integrated flight instruction, is not relying just airspeed indicator, but also the attitude indicator as a primary center of focus. And what does the airspeed look like on the attitude indicator for that phase of flight? Teach at higher altitudes, different flight scenarios, different angles of attack, and that should help the student not focus on just airspeed indicator, also see what else other instruments are backing up to confirm.
May I add one other comment to that question? It's a very good question, by the way, very insightful for whomever asked it. Another thing that as a CFI I always really emphasize strongly is, look, at every point in the pattern, your eyes should be outside. We heard it clearly from the Remora Systems folks. It's an important phase of flight that you can't be looking inside more than a quick glance on occasion. So if you haven't done this already, go out with an instructor and train. What are the different sight pictures for different power settings? You don't have to look at a tachometer to tell what your power setting is. You can hear it. Where's the horizon line on the windscreen? And start to correlate those things. Get to the point that you almost don't have to look inside the cockpit because you know exactly what the aircraft is doing. That's truly the next step for that individual.
You can safely fly a pattern without an airspeed indicator if you understand pitch attitude power relationships, and everybody should get that feel. And therefore the glance is just a confirmation. You know where on the airspeed needle that or indicator that needle should be, and it's a quick confirmation, but it's done based on looking outside pitch attitude. Where's the throttle? Does it correspond? Is it giving you the performance you expected?
Not to give the impression that on final approach, speed is not important. I mean, that needs to be constantly in the scan, inside and outside and inside and outside. That would be my thoughts. Thanks. Doug?
I don't want to be redundant. Charlie beat me to the punch. Every combination of pitch, power, and configuration yields performance. Every one of the pilots that I've taught to fly has had to fly with all their instruments covered up prior to solo. Explaining that process of pitch, power, configuration, energy management. And so I'd recommend to this person who's asked the question, if they can find an instructor who's certainly able and willing to do that, he might really solve his problem right then and there.
Great, thank you. I'll go to the last question that we have from the audience, and we will continue to take questions after we come back from the break. I won't decide who this is for, but it might be for Brad and for Doug, but might be for someone else. The question from online is, how do we train the trainer to be better at explaining and teaching AOA and stalls in the private pilot curriculum? So whoever would like to take a stab at that, but Doug, you might be a good one to take a whack at that.
How do we train the trainer to teach properly? This is a kind of tough one because it really began long before they decided to become a trainer. Where we start is at that very first lesson. And if we train our current trainers to teach with integrity, we shouldn't have that problem. I think it sounds real simple, but I think it is that simple.
Thanks. Brad, I just thought since you're dealing with the Airman Certification Standards, maybe you would like, since it said curriculum, but any thoughts on that?
Yeah, no, I completely agree with what Doug has said kind of in the break. We also talked about professionalism and how that needs to be incorporated into not only how we function as, you know, a two-person crew up there, flight instructor, student, but also how we test. And risk management is also a key component of that. And that's
obviously in the ACS, to your point.
Great. Well, tell you what we'll do. We will take a break, and I'll talk about that in just a moment. But while you're on break, when we do come back, what we're going to do is go around the room and get thoughts from each person on the future, the challenges, and the next steps for what we need to be doing to prevent loss of control in flight. So that's what we'll do. The time is 1:39. We'll be back at 2 o'clock. Thank you very much.